Okay, let's talk about 75 through 84. Here we go. Number 75. This one is a proportion. 2/3 equals n over 8. To understand, since it says equals, I know that this is a fraction equaling another fraction. I'm going to give you another fraction that I know something about. 1/2 is equal to 4/8. I hope you'd agree with that. In any fractions that are equal, these two multiplied will equal these two multiplied. So 1 times 8 is 8, and 2 times 4 is 8. Okay? That'll be true on any two fractions that are equal. Okay? If you think of any two, like 3/4 and 6/8, if they're really equal to each other, then this times this will equal this times this. 6 times 4 is 24, 8 times 3 is 24. It's true. Now, how does that help us in this problem? Because then I know that this times this has to equal that times that. And I can set up a proportion. 8 times 2 is 16, and 3 times n is 3n. And remember, those are equal to each other. That's the point here. And so from there, it's going to be really easy. I just have to get the n alone. So I divide by 3 on both sides. And I have, and I'm going to reverse this first. 3n equals 16. I just like it better that way, with the variable on the left. And now I'm going to divide by 3 on both sides. And I'll have n is equal to 16 over 3. Okay, that's all there is to it. Whenever you have two fractions equal, you've got a proportion, and you set their cross products. They're called equal. So if I had 4/5 equals, let's put the number on top, 2 over n, I can cross multiply. 4n equals 10. And then I divide by 4 on both sides, n equals 10/4. I really should reduce that, n equals 5 over 2. So there's another example. All right, moving on. Another type of equation you need to solve is the simple, I've got a number in front of a variable. Remember that means times, okay, if it's right snugged up against it, and you have to get rid of the number in front of the variable. So that is a times by 2. How do I undo that? With dividing by 2. If I divide by 2 on the left side, I got to divide by 2 on the right side. And then these will cancel, which really means turns into 1s. And then I've got a over 1, which is just a, equals 9 over 2. And that's a good enough answer. If you want to say 4.5, sure, that's fine. All right, so let's say it had been 7m equals 23. Again, I got to get rid of the 7. It's being multiplied. How do I undo multiply? With divide. Final answer, m is equal to, after these cancel off, 23/7. So just divide by that number in the front. All right. I guess the better, safer thing to say is do the opposite of whatever has been done to the variable. So let me give you one more example. Let's say it had been a minus 3 is equal to 20. Well, there's a simple one-step thing to do. I got to get rid of the thing by the variable. This time, though, it's not being multiplied. This time it is being added or subtracted from. And how do I undo a minus 3? With a plus 3. If I do it to the left side of the equation, I got to do it to the right side of the equation. And so I'd have a is equal to 20 plus 3 is 23. Okay, so do the opposite of whatever's been done to the variable. Here the variable was times by 2, so we divide it by 2. Here the variable has had 3 subtracted from it, so we add 3 to undo that. All right, moving on to the next kind. So often you come down to a negative variable, and kids are flummoxed. So here's what you need to do. Think of this as a negative 1 times the a, and it'll be easier to understand how to get rid of it. To get rid of negative 1 times a, I can divide by negative 1. If I divide by negative 1 on the left, I got to do it on the right. And so I'll have a is equal to 2 divided by negative 1, which would be negative 2. Now, some people prefer to just think of this as, well, if negative a is equal to 2, a is equal to negative 2. That's fine. But really, you can just think of this as a negative 1 that you have to get rid of. And you do it the same way you get rid of other things that are being multiplied by a. You can divide by it. Another trick is to think, if that's negative 1a, how can I get rid of it? I can times by negative 1, because negative 1 times negative 1 is also positive 1. So it would work. If I times by negative 1 on both sides, I'd have positive a is equal to 2 times negative 1 is negative 2. However you slice it, this answer comes up to negative 2. All right, moving on. 2/3 n is equal to 6. How do I get rid of that fraction? Well, there are two ways I'd like to have you consider. First thought is, if you have fractions in an equation and you don't want them, multiply by the common denominator. That will get rid of it. So for instance, if I want to make this into not a fraction anymore, if I multiplied by 3, it wouldn't be a fraction anymore. Okay? So if I multiply by 3 here and multiply by 3 here, that's fairly easy. And these 3's will cancel, turn into a 1 and a 1, so they'll turn into just 2n equals 6 and 3 is 18. And then you can use your other rules of get rid of that 2 by dividing by 2, and you get n equals 9. Okay, so that's a good way to do it. You're getting rid of the fraction in the problem by multiplying both sides by 3. But there is a little faster way to do it. If you want to just get a 2/3 off of there, or some other fraction off of your variable, you can multiply by its reciprocal. So 3 over 2. And if I multiply by 3 over 2 here, then these guys will cancel. I get n is equal to, I'm going to make this a 6 over 1. 6 times 3 is 18. 1 times 2 is 2. N is equal to 9. Okay, so either way the answer is 9, but you can do this in two different ways. All right? I'm going to recommend that you know both ways, because depending on the problem, you may want to use either one of those methods. Okay, so again, if I had 4/5 y is equal to 20, I could either multiply by 5 on both sides, and then I don't have fractions anymore. Or I could multiply by 5 over 4 on both sides, and then these will cancel. They all become 1, 1, 1, 1. So it's big 1y is equal to 20. I'm going to put it over 1. Is 100 over 4, which would be 25. All right. Let's move on to the next one, number 79. This is a classic two-step. No, it's not. I thought I had 2 steps, but really, I've got variables on both sides. That's the thing that I got to fix here. Whenever you have variables on both sides, don't go trying to add a number to both sides and, like get it, like a lot of kids start by subtracting 1 here. That doesn't really help you. You've got to get the variable alone, and the variables are on both sides, and that's a big problem. So you get rid of the smaller of the variables that are on both sides. Okay, I got a 2n or I got a 9n. Which one's smaller? 2n is, so I'm going to get rid of it. And if I take away 2n, that will make it go away. If I take away 2n here to keep it balanced, then these are gone, and I have 1 equals 9 minus 2n, which would be 7. And it's not solved for n yet. I really like to write it this way. You can always reverse it like that if you want. And now I'm going to say divide by 7 on both sides, n equals 1/7. Okay? So if you have variables on both sides, get rid of the smaller one. And then this sometimes comes up. Negative n plus 5 is equal to negative 5n. Well, if I'm trying to get rid of the variables that are on both sides, I got to get rid of one of the two. Which one's smaller? And first of all, you need to be pretty smart to know that that's smaller than that. Okay, so I'm going to get rid of that one. So I do the opposite. I'd add 5n to both sides. But a lot of kids get scared here because they're like, wait a minute, that's just going to go away. It's okay. What is negative 5n plus 5n? It's 0. And it's okay to have it just go away like that. Just put a 0 there. And now I have a 5, and then I have a negative n plus 5n makes 4n. Okay, so I still did what I told you, which was I got rid of the smaller of the two variables on both sides. I got rid of this one, okay, by adding or subtracting that to both sides. Now I'm going to subtract 5 from both sides, and I got 4n equals negative 5, and then I'd have n is equal to negative 5 fourths. I'm going to divide by 4 at the end. All right, variables on both sides. That's a big one. Let's move on, number 80. N plus 1 is equal to n plus 8. Well, again, the real confusing one for a lot of kids, because they're like, well, I gotta get variables on both sides. I could, and they just don't know what to do. Well, you've got variables on both sides that are exactly the same. Which one's smaller? Well, they're the same, and so I get rid of n on both sides, and I have 1 equals 8. Well, anytime you end up with an equation like this where all the variables cancel out, then what you got to do is look at what you have left and see if you're left with a true statement or not. This is a false statement. And that means that there are no solutions, no real numbers. Okay? I'm just going to use this sign. It technically means empty set, but I could say no solutions. So there we go. Oh, brain block there. If I wanted to do one that came out kind of the same but a little different, let's say I had n plus 2 is equal to 1 plus n plus 1. Okay, now I have variables on both sides, and I get rid of the n, and all of a sudden I have 2 equals 1 plus 1, 2 equals 2. If you're ever left with a true statement, then that means, different than this one had no solutions. This one, anything would have worked in here for n. So all real numbers are the solutions. Okay, all, and this is a kind of a shorthand we a lot of times use for real numbers. A big capital R with like 2 bars. Okay, all real numbers work. So you're either going to end up with if all the variables drop out, you're either going to end up with something that's true or false. When it's false like this, there are no solutions. If it comes out to a true statement after all the variables drop out, then it's all real numbers are the solution. All right, moving on to 81. This is just like the other one where we had 2 fractions set equal to each other. And the reason I put it into the list is that, yeah, you're still going to go this times this equals that times that. It's the same as the previous one where you have proportion, statement 2 fractions are equal, like 1/2 equals 6/12. I know that this times this has to equal this times this. Okay, 1 times 12 is 12, equals 6 times 12 is 2 is 12. So it's still true to cross multiply like that. But here's where kids will mess up. They will just go 8 times n is 8n, and then they think they're done multiplying that 8. You've got to multiply it into both parts. 8 times the n and 8 times the 3 is equal to 2 times the n. Okay? So this is set up right now, and now I got variables on both sides. I take away the smaller one. Don't let it freak you out. Over here it's going to equal 0. And I have 6n plus 24 equals 0. There'll be something over there in a second. I go 6n, I can take away 24 from both sides. And I have 6n equals negative 24. And then I have n is equal to negative 24 over 6, which is, let me see, so negative 4. All right, so the moral of the story here was really this part where we multiply the 8 times the n plus 3, that you have to really think of this as n plus 3 in parentheses times 8 equals these two, n times 2. And this would then distribute out, and you'd have 8n plus 24 equals 2n. Okay, so don't forget to take this and multiply it by both parts of this. All right, moving on, number 82. Negative 3x is less than or equal to 6. All right, this is our first inequality that we've talked about so far. Inequalities are solved just like equations are solved. They have the same kind of rules, except when you have and when you ever multiply or divide by a negative. All right, so I'm going to act like this is negative 3x equals 6. If it were, what would I do next? I'd get rid of the negative 3. It's being multiplied here, so I would divide both sides by negative 3. Okay, so I just do the same kind of rules, but I'm going to bring the correct sign down here and say, if it's negative 3x less than or equal to 6, I'm going to divide by negative 3 on both sides. And as soon as I divide or multiply by a negative, that sign has to switch. Don't forget that part. It's really easy to forget. And 6 divided by negative 3 is negative 2. All right? So if I wanted to check myself to make sure I did this right, I could pick a number that's bigger than negative 2, like 2 is, and I could check and make sure that 2 actually works, or 5, or anything that's bigger than negative 2. So let's try 5. if I stick in a 5 here, negative 3 times 5 is negative 15. Is that really less than or equal to 6? Yeah, negative 15 would be, so it worked. All right, so there's your quick answer to how do you do a inequality. Just make sure you don't forget the part about if you ever, in the course of solving an equation or inequality, multiply or divide, like this I divided, by a negative, you've got to switch the signs, okay? It does not mean just because there's a negative in the problem that I have to switch the sign. So here's another one. And a lot of kids say, oh, there's a negative in the problem, got to switch the sign. No, it's only if I multiply or divide by a negative that I switch the sign. So here I would just add 1 to both sides. Remember, they act just like an equation. X is less than or equal to 7 plus 1 is 8. Notice I did not switch the sign. Okay, only if I had multiplied or divided here by a negative, then I would have switched the sign. All right, moving on to 83. Absolute value. Absolute value of 6. That means how far away from the origin is 6. Okay, so here's a number line. Here's the origin, 0. And 6 is at 1, 2, 3, 4, 5, 6 spots away. Okay? And so really, it's how far away is it from the origin? Well, it's 6 spots away. The answer is 6. Okay? But the thing is, if I do absolute value of x is equal to 6, I mean, what I just kind of answered was the absolute value of 6 is 6. But when you're doing a absolute value with a variable in it, then you got to understand that there are 2 things that could work. Just think of it this way. Wouldn't the absolute value of 6 be 6? Yeah, because it's how far away from the origin is 6. And the other thing that's 6 away from the origin is negative 6. So there's 2 things that would have worked in here. Negative 6, the absolute value of that would be 6. And negative 6 and negative 6, so the answers is the bottom line. So here's how you do an absolute value with a variable in it like this. You split it into 2 parts, and you rewrite it as x is equal to 6 and x is equal to negative 6. Okay, so you always take your absolute value and split it in 2, because I know that this is what's in here has to either be 6 or what's in here has to be negative 6. So I write it out both ways. All right, so there's my answer. X is 6 and x is negative 6. All right, so let's say it had been a little more complicated and say it was 2x is equal to 8. Well, you write it out both ways. Either 2x equals 8 or 2x equals negative 8. So you split it into the 2 parts. And they're both right answers. So if I divide by 2 here, I'd have x equals 8 divided by 2 is 4. And I divide by 2 on both sides, x equals negative 4. That means if I stick in a 4, it should work. 2 times 4 is 8, and the absolute value of 8 is 8, so that worked. Or I could stick in negative 4. If I put in negative 4 here, 2 times negative 4 makes negative 8. Absolute value of that is 8, so it worked. So there's 2 answers. Okay, so when you see an absolute value, you got 2 answers likely that are going to come out. Okay, this one is one of those a little bit more complicated absolute values. So like I just showed you, you split this into 2 parts. Okay, and I'd have 3x minus 1 is equal to 5, just like it reads in the first place. But what is in here could also be negative 5, and it would work. So I say 3x minus 1 equals negative 5. See, they're identical to each other, except this one has a negative in front of the right side. All right, now to solve it, I add 1 to both sides here. I'm going to go plus 1, and I have 3x equals 6. X must equal 2. And over here, add 1 to both sides, and I have 3x equals negative 4, and x equals negative 4 thirds. All right, so I got 2 things that could work and give me the right answer. If I wanted to double check, I would take my 2 and stick it in right here and make sure it worked. 3 times 2 is 6. 6 minus 1 is 5. Absolute value of 5 is 5. It worked. And this negative 4 thirds doesn't seem as likely to work, but only try it once. If I stick in a negative 4 thirds here, negative 4 thirds, I take 3 times negative 4 thirds, 3 times negative 4 thirds minus 1 in absolute values. These 3's will cancel and turn into 1's, and so it's Negative 4 divided by 1, which is negative 4, minus 1 makes negative 5, and the absolute value of negative 5 is 5. It worked. Yes. All right, so when you have absolute values like this, split it into two parts. The only other thing I want to say about this is if the absolute value gets even more complicated, like it's got like something in front of it, like 7 absolute value of 2x minus 3 equals 12. You've got to get rid of anything that's cluttering up the absolute value side. You got to get it down to just an absolute value before you split it in two parts. So like here, I'd get rid of the 7 by dividing by 7 on both sides. And so I'd have, after these cancel, I'd have 2x minus 3 in absolute value equals 12 sevenths. Then I can split it into my two parts. 2x minus 3 equals 12 sevenths, and 2x minus 3 equals negative 12 sevenths. So you can't do the splitting like this until you've gotten it down to just an absolute value. If I would have split it right at the beginning here where I had a problem with 7 in front of the absolute value, if I would have split it then, I would have gotten it wrong. I need to make sure that I split it up only after I've got it down to just an absolute value all alone on this side of the equation.